Okay, so for part A, here we want to make a graph. First of all, we notice that there's a 1/3. Okay, so as far as graphing things, all of our exponential graphs always have the point 0, 1. And now if you plugged in 1 into your equation, you would get 1, 1/3. Maybe you recognized already that it was going to be decreasing because it was between 0 and 1. You could label other points as well. What would happen if I plugged in 2? I would get 2, square that, 1/3 times 1/3 becomes 1/9. How about negatives? What happens when you do 1/3 to the negative 1? Okay, mental math. It's going to be 3. Remember how to do that? Okay. First of all, that exponent goes to both of them if you would like. And then you have to say, well, what does my negative exponent do? Negative exponent just means you're going to move it to the other side of the fraction and make it positive exponent. So that would be 3 to the 1 over 1 to the 1, which is just 3. So you can plug that in if you wanted some more points. And this is our graph. Draw arrowheads, add your asymptote at y equals 0, and there we've got a graph. So what happens every time x increases by 1? Y gets multiplied by 1/3. So every time you add 1 to x, you're going to multiply y by 1/3. As a result, this function is decreasing. It's going down. There are no x-intercept, but our y-intercept when x is 0 is equal to 1. Our equation of our asymptote, it's a horizontal asymptote at y equals 0. The domain is everything, and the range is greater than, but not equal to, just greater than 0. So 3, 5, and 7 are some questions that you can do. Now, going back, here is an explanation of your transformations unit with exponents. I'm going to say we are not going to remember this, even though it's really easy to read. Right? It would be super easy to remember because of that. No. We're going to use the same thing we've always done in our transformations, which is we're going to go from left to right like we've done before. And now the only thing that's new is your transformations unit. You have to know all of your exponential parent graphs to start with. And so you have to be able to graph y equals 3 to the x, y equals 5 to the x, y equals 7 to the x, y equals half to the x, y equals a third to the x. And the way that you're going to start with your parent graph is you're going to have always the point 0, 1, always an asymptote at y equals 0, and then one other point, 1, whatever your base is. And then you're going to work from left to right to do transformations. So we're going to see what that looks like. We're going to, at the bottom of the page here, we're going to add an example. We're going to graph y equals negative 5 times 3 to the 2 x plus 4 minus 7. So the first thing that you have to determine is what is your parent graph or your base graph. What is the exponential graph to begin with? And then we're going to have to determine what's vertical, what's horizontal, what affects your x coordinates, what affects your y coordinates, and how that works. So, first of all, we recognize that our x is in an exponent. So your base graph is going to be y equals something to the power x. We have to look here and say, what is the base of the exponent in that original function? Okay, is it the negative 5? Is it just the 5? Is it the 3? Is the base the 2, the 4, or the negative 7? It's going to be the 3. So this is our base graph. Because the exponent, can you see the exponent is right here in the red box? That's the exponent to the 3. That exponent isn't to the 5. Okay? Which is important because if you think of your order of operations, what word did you learn when you did order of operations? Bedmass. And the B stood for brackets, or some people learn pedmass because they learn parentheses instead of brackets, but whatever. And then E is exponents, which is next, right? So one of the things you are going to be tempted. This is a good question for temptation right here. Do you see that it says negative 5 times 3? What are you going to want to write so badly? Because you're like, I'm good at mental math. You're going to want to write negative 15 so badly. Okay? But you have to remember that bedmass, the order of operations, say exponents happen first. So unless you do 3 to the power 2x plus 4 in your head and get a number, you can't multiply that 3 by the negative 5 until that's done first. So that's important that we don't multiply the negative 5 and the 3 together. Anyways, our base graph is 3 to the x. So what we do is we draw a little tiny sketch. 3 to the x looks like this. It has the point 0, 1 and 1, 3 and an asymptote here at y equals 0. That's your base graph. So what's added from our transformations is we now have to be able to draw base graphs of all of our exponentials quickly and easily. Now what we can do is we can go from left to right and take these 2 points and our asymptote and look what happens to them. Okay? Going from left to right. First of all, what I'm going to do is I am going to, with a highlighter, highlight my base graph in my function so I don't do a transformation using that 3. This is what makes exponential questions a little bit harder with transformations because there's another number in there that's actually part of your base graph. And you might be tempted to include that in your transformations. But now that I've highlighted that, the first number, the minus 5, that's going to be a vertical stretch. So if we draw an arrow, we have to do y by negative 5. Inside we hit a 2. What's that 2 going to do? It's going to multiply x by 1 over 2. Good. So that's the first thing that's going to happen. If I multiply x by 1 over 2, I'm going to get 0. Y by negative 5, 1/2, and negative 15. Next, we have the plus 4. Notice in this question that I made, I had already factored out the horizontal stretch. Because we made a special note before that said if you have a horizontal stretch and a horizontal translation, it always has to be in factored form. And this question in that red box that we see, it is already factored. So that's nice, we didn't have to do that extra step. What that means is that plus 4 means which direction are we going to go, left or right? Everything that's in that red box is the opposite, right? So our 2, instead of multiplying x by 2, we multiplied it by half. And that 4, instead of going right 4, when we see the plus 4, we go left 4. And finally, the 7 will mean that we're going to go down 7. So left 4 will take us to negative 4, down 7 to negative 12. Left 4 will take us to negative 3.5, and down 7 to negative 22. What is going to happen to our asymptote? Well, first of all, our asymptote is y equals. So it's only going to get affected when you do things to your y coordinate. When you multiply 0 by negative 5, nothing happens. In fact, nothing happens until you move it up or down. Hello? So then when we move it down 7, our asymptote becomes y equals negative 7. Now we have enough information to draw this graph. What you're going to do when you're graphing your exponentials after transformation, you're going to start with your asymptote. Label it y equals negative 7. Then we're going to label the 2 points that we found. We have 4, negative 4, negative 12, and so negative 4, negative 12, and negative 3.5, negative 22. Just sort of estimate, make an estimate where those would be. Between those 2 points, do you see that it's going down as I go towards the right? So as far as where it approaches the asymptote, it'll approach it this way and go down like this. Now, if we think about our transformations for where we started with, the first thing that happens is y was multiplied by negative 5. The negative 5 would stretch it and flip it down. Can you see when I flip it down that it would get this kind of shape? Then it's compressed horizontally. We move it 4 to the left, 7 down, and this is where we'll end up. So we do get to review a little bit of our transformations unit in this unit, because we learn these new graphs, and now we get to graph all of our exponential graphs with all of our transformations. Oh, no, there's no additional questions.